We have Benzi Galili with Scale MP. There you go.
Okay. Good morning. And hopefully some of you were, I hope, at the keynote yesterday. And what I'm going to talk about today is really the distinction between the software-defined memory technologies that I mentioned yesterday that you could take advantage of in order to increase what you do in memory, expand its capacity or lower its cost, and how you select which one is better for what you're trying to achieve. So yeah, we got a system here, a server, and we want to have more memory. Okay, that's a key thing. If really what's bogging us down is that we don't have enough memory, not the CPUs and not the I/O, just the memory thing is what our problem is, because we want to do more in memory. We want to go bigger in memory, and then the two alternatives I explained about yesterday are software-defined memory over fabric and over storage. Over fabric being add additional systems. Okay, their CPUs could be dumbed down CPUs, the lowest cost of them, or any other that you have in your fabric that you're not using. Really, those become memory contributors. So looking at this side, these two nodes here, these two server nodes, no I/O, nothing on them. Basically, they're serving the memory for you. In order to add this capacity of the memory here, so if this server had 500 gig and these two each had 500 gig, you end up with a terabyte and a half of DRAM. Okay, the ability to do this is also on demand, meaning you could say, hey, I've got this cluster here, I need to do this operation, add these two nodes that are not used into my infrastructure to have a bigger memory machine. And the other solution I mentioned yesterday was the ability to use storage devices, high-end storage devices, as and you know, Rob earlier mentioned what kind of devices there are today and where they're going to, as memory, transparently. So in that case, we have the server here, only I took part of the storage and made it look like memory, completely transparently. And now I can, you know, the applications and operating system just see that as memory, as if more memory is installed. And really from here on, you just use your applications. They happen to have more memory now. So the attributes of these solutions are different, and that influences, of course, which one is better fit for your application and your budget and so on. The software-defined memory over fabrics is something that's been out there for years. We've got clients running very large in-memory databases using this technology, doing scientific work using this technology, and really at the bottom of it is an engine that allows you to make sure that whatever the CPU wants to use, it's already local to the CPU. Even if it was originally on a remote node, it's transient, and we make sure that before the CPU that runs the application actually tries to use that, it becomes local to it. So eventually, you're seeing nanoseconds, which is what memory latency is. You're not seeing the very high latencies. And if you remember the benchmark examples from before, we're showing almost DRAM performance, 98% of the 100% throughput of an in-memory database running that way. So we've got those different techniques, and there are many of them. So if you want to hear more about them and what they are, I'm outside in our booth later on, and happy to discuss those in more details. It's also very simple. It's simple by design. You run your favorite Linux flavor. You can deploy this locally, or you could deploy it from your favorite provisioning environment. And allows you to save where you can. You can use a switched fabric, or if you want to just create a small system that fits a specific application, you don't need a switch. You can, if you're building your own system, you can have systems with lower cost CPUs, serve as the memory contributors, so on and so forth. Overall bandwidth between the nodes, and bandwidth is important when you trade latency and bandwidth. Overall bandwidth that we provide allows you to aggregate many links between the machines up to 512 gigabit per second. So that's a lot of bandwidth between the nodes serving the DRAM. And there's a free version available. So you could go online, download. Of course, it's community support, not usual support. But you could get it, install it, see how it works for your application, experience what it actually is. The software-defined memory over storage is newer technology. It basically leverages everything we've done and all the knowledge we've gained from production systems with software-defined memory over fabrics. And we, of course, had to enhance it to make sure that it's adjusted to the media attributes. Storage, even very fast NVMe devices, has other attributes than very low latency fabrics that are available today. And so you want to make sure that you're able to take advantage of the storage as best as possible. You want to have things like asynchronous memory accesses, even though the OS thinks that the memory is synchronous. You want to have the ability to go deeper into how much you prefetch. You have very high bandwidth on those devices, on those NVMe devices, so you could prefetch a lot, and we do a lot of that, very advanced caching. So these things were added to the technology stack to be able to take advantage of that. And of course, storage means that you have, at the end of it, some NAND or other type of NVM. Those have durability limits, and you want to make sure that you're not killing the device because it wasn't planned to be a byte addressable thing. It was designed to be a block device. And you don't want to drop down in the number of years it can actually serve a customer. So having discussed all these attributes, this is really my last slide. What does it mean? When you select the type of system that is right for you, how do you select which of the technologies is best? And of course, one of them has this attribute that it's almost good for any workload, but it's more expensive, and therefore getting down into the details, because sometimes you don't have to spend that extra money or you don't have that extra money. So first of all, we handle any type of workload, including the ones that are hard to predict, including the ones like Memcached, which really look like random accessing. We've got all the solutions for that built into the technology, and they work really well. If your workload is not concurrent, and the best example for that would be, let's say your application is really a single-threaded Python script, okay? That's not going to run well on the SDM over storage because we couldn't leverage the concurrency, okay? So everything that we've done nicely with trading off the latency with the bandwidth, there's no trade-off to do. You only have a single process running, okay? Not much we can do about it. In that case, really, the fabric is the only option you have. When you're looking at the overall use case that you're using, you could really either want to expand your overall capacity or you would like to lower the cost of your capacity and replace the expensive DRAM. Thank you. The fabric option really is using more RAM. So if your platform can take more RAM into it, no reason to use the fabric option. Just plug more DRAM into your system. And that pretty much brings us to the next line. If you could get enough memory in systems today, it's anywhere from 700 gigs to 3 terabytes of systems that you could order from Dell or Lenovo and Supermicro and so on, then probably that's not where you want to use the fabric option. You'll be buying memory anyway, DRAM anyway. But you could use, very cost effectively, flash in those, or NVM in those environments. So you could build a 3 terabytes or a 4 terabyte system memory machine with just 500 gigs or a terabyte installed, and then the rest in flash. That will save you a lot of money and give you this very, very close, same performance. If you want to save on the cost of your memory overall, compute, especially Rob mentioned before, things like big grid doing Monte Carlo, I'm practically done. Monte Carlo simulations with a value at risk, those tend to have spikes. You don't know what your Monte Carlo would be doing. You want to put enough memory in the server, but you don't want to over-provision RAM, which is very expensive. Then the flash solution would be great for you. I've had people ask me, so I added this line actually as a result of conversations outside. People ask me about deploying this on clouds. If your cloud provider gives you bare metal access, you can deploy the technology to the cloud. If you have, if the cloud provider does have the high-end fabrics, you could use the over fabric option. Otherwise, you're left with flash for those bare metal clouds. Thank you very much.